is in processing technologies. Um, so whatever information I present here, it is more from the technology side rather than on the microorganism side. So the outline for my presentation is that initially I will just show you some of the common foodborne pathogens, especially here in US, associated with the foodborne illnesses. Some of the foods which are, found to, with foodborne illnesses. What are the current food processing technologies we have, which we use to address food safety and quality problems? What the advanced technologies we are working on, our scientists and industry is working on for improving food quality, and what advanced technologies are, again, scientists and industry are working to improve the food safety. So if you look at the food safety within the United States, food poisoning, there's a typo here, in US is 1 in 6 American get affected by food poisoning, and there's about 48 million people annually are affected by food poisoning. And out of that, there are 128,000 hospitalization. There are 3,000 deaths associated with food poisoning, and cost of the health care for these foodborne illnesses, it goes in terms of the billions of dollars. Many millions of cases, we never detect what kind of microbes or viruses have really caused this illness. And majority of deaths and hospitalization, we actually never learn. Of course, people get better, some die, but we never learn, what kind of microbes they have been really affected, in that particular food. So it's really a big challenge to safety. So why are we seeing more foodborne outbreaks, pathogen outbreaks? This is simply because, over the years, there have been a lot of changes in the food production system as well as the supply. If you go 4 or 5 decades back, most of the countries, there was a local production in a, area nearby, and the food, the fresh vegetable, meat, milk, it would travel probably only a few kilometers, and then it would consume in that community. But now it is just not crossing the cities, but countries, even continent, so what anything could go wrong in the entire this big supply chain. There have been a lot of changes in terms of the environment, which has also led to food contamination. We now have many more detection technologies, and sensors and instruments, where we are able to quickly learn that there is a multi-state outbreak. So it means that food produced in one state, if it has traveled to 20 other states, we can quickly track and figure out that these kind of outbreaks are happening. With time, we are seeing new strains, new toxins, new antibiotic resistance in those bacteria. Of course, over the year, consumer preference and habits also have gone, they have changed. And the tests that diagnoses foodborne illnesses also have been, improved. So altogether, we see actually a lot more outbreaks compared to what we used to see, a few years back. So if you look at the entire food production chain, the contamination could occur at any point in the supply chain, So let me make this, So, for example, food contamination could happen at the production, at the farm itself, with fruits, vegetable, animal-based food, or even with the fish, And then as food travels, through the processing facility, distribution, then goes to either restaurant or retail. From retail, it could go home. or from retail, it could go still, restaurant may buy and then it used for the food service. So the entire supply chain or production chain, food can get contaminated by handling surfaces, for example, equipment, storage bins, processing line, packaging, water which is being used for washing, for example. As food travels a long distance, if there is a temperature abuse in the cold chain, that could also lead to, microbial growth. Surfaces may be contaminated. Sometimes at home or even as restaurant, you may have, sick people, food workers who are not washing their hands, or sometimes, food is fine, but the surfaces like cutting board, knives, they are contaminated. And sometimes one food is contaminated, it is kept with the another food, in refrigerator or any storage place, that can also contaminate the other food. So along the supply chain, there are many, many different, avenues where food can easily get, contaminated. And again, as I mentioned, if you go back, a couple of decades where food would not travel such a long journey, you grow in a nearby village or area, and then, within few kilometers, it is being consumed, not going through many hands. But that's not the case nowadays, especially here in the United States. And if you see the foodborne pathogens are responsible for illnesses, you have Listeria, E. coli, Salmonella, Vibrio, Clostridium perfringens. You also had two viruses like a norovirus, hepatitis A. Thank God coronavirus is not foodborne. It is just going from human to human. But, viruses have been also associated, these two, with the foodborne illnesses. And staph and Campylobacter is also, most common responsible for the foodborne illnesses. These outbreaks, is associated with many, many food products and different categories. You see with fruits and vegetable. In US now, cut fruit and vegetable is a big market. People just don't have a time and interest in chopping their vegetables or, peeling their fruits and cutting. So, industry is delivering for them. Nevertheless, because it is again going through different handling surfaces and through different supply chain, very long supply chain, you see contamination, and then that leads to the outbreaks. Raw milk, interestingly, in US, even at some places, the raw milk is sold, and it's expected people will buy and sort of boil and pasteurize at home. But in case if they are not doing sufficient, pasteurization at home, then that can lead to outbreak. Eggs, ground meat, poultry, shellfish, sprout, soft cheese, apple juice, salads, and interestingly, even spices and nuts are also associated with outbreaks. Interestingly, we always thought that low water activity foods are safe because bacteria cannot grow, so these foods are safe, but that's not the case. That is true that bacteria cannot grow in this low moisture food product, but they can survive, especially Salmonella has shown to survive for many, many months into the low moisture food such as spices and food powders and nuts. And in case you are adding these spices and nuts into the other food recipe where you are doing sufficient cooking, then probably it's still fine. But in case if you add these spices to the already cooked food where you're not doing any other, intervention, and then you are leaving that cooked food for a very long period of time, then if there is one or two cells of bacteria survived in that spice or any powder, can grow over the time, and then it can cause foodborne illnesses. Yeah. So, for example, in some recipes, from the Indian context, if let's say if you have a kheer, and then you want to add some almonds in it, and if the almonds are contaminated, you know, um, and you add these almonds into the kheer, and then if you're leaving it for, let's say even at refrigeration temperature, for low temperature, or for a few hours at room temperature, that's a sufficient time for bacteria to just simply multiply and grow. Same way, there have been some outbreak associated with the frozen fruits. That happens, for example, when you are freezing, let's say some berries, or cut fruits, after washing them, you are freezing, and during freezing and packaging, if there is some contamination there with the food handling surfaces or packaging surfaces, of course, at frozen temperature, bacteria would not grow, but they may survive. And when you are thawing the product for a long period of time, then they have opportunity to again multiply. And then if you are adding these, fruits and into, let's say, smoothies or milkshakes, and then there again you are keeping for some period of time, then again they find, opportunity to grow and multiply. So that's how there have been many, many outbreaks associated with some foods, which we never thought, with those food ingredients, because we are not using those ingredients alone. We are somehow adding into the other recipes where they find, enough moisture and time to grow and multiply. So because of that, we see many, many outbreaks. And now, because we have detected the problems, people are looking into the, sort of technologies and intervention method, how we can minimize these outbreaks. So if you look at all food processing technologies so far, humans, they have developed, which have been industrially successful or commercially successful, I can divide into sort of two categories. One, these technology which are primarily used for the preservation. For example, aseptic processing and packaging technology, retard, where using these you can do thermal processing like sterilization and pasteurization, and depending upon the temperature range you are using and the time you are using. Their mechanism is that you use heat to kill pathogens as well as the spoilers microorganisms to improve safety and extend the shelf life of those products. Another preservation technology is freezing, where the mechanism is that you have the water which is available in fresh produce or meat or poultry or fish. You convert the water phase into ice, so that water is not available for microbes to feed on, grow and multiply. So then your food is preserved. In case of drying technology, the mechanism is that you simply remove the water. So water is not available for microbes to again grow and multiply. So this is how you kind of course, you have the fermentation technology as well. But the primary principle here is that you are preserving the food. However, there are some other processing technologies such as baking, frying, extrusion. The product gets preserved. You have a good shelf life, but the purpose is not really preservation. Purpose is like you're formulating new ingredient. For example, in case of a baking, you take a wheat flour. Well, wheat flour you don't have to preserve. It is a low moisture food. It is preserved. But then you add water and some other ingredient, and then you bake it. So you make a new product. Of course, the baked products also have good shelf life, depending upon its moisture content and ingredients you have. Same with the frying process. You take potato. Potato have a reasonable shelf life, even at room temperature, and of course at refrigeration temperature you have good shelf life. But then you are frying it to convert into a different product. Same way extruded products, like a pasta. You take wheat flour, you add water, but then extrude it, make a new product. So these are truly not preservation technology. They are more like a new product development technology. Nevertheless, the final product, what you produce, is also preserved. But what are the limitations with these current technologies? So if you look at carefully the technologies, what I showed you in the previous slide, most of these technologies, for example, sterilization and pasteurization or freezing, they are primarily developed for high moisture product, meats, fruits, vegetable, liquid food, like, milks and juices and so on. You sterilize and pasteurize, and based on the treatment, you have certain level of shelf life. It could be days and could be years in case of a sterilized food product. Another characteristic with this technology is that product gets cooked. So when you do sterilization and pasteurization, especially using heat, the product gets cooked. So it's kind of, you have cooked product. Many times this is desirable, but not always, But also, these preservation technologies or processing technology, it affects the quality attributes. For example, you have significant nutrient degradation in case of a thermal processing. Texture, flavor, color may be affected due to thermal processing, freezing, or drying. Existing technologies. So there is a really need to develop new technology to improve the food quality, which means that you want to minimize the food degradation with, a quality degradation with traditional processing method, and also to improve the food safety of especially fresh produce and low moisture food. Fresh produce, for example, tomato, lettuce, spinach, you don't want to sterilize and pasteurizing using heat because they will get cooked, and you are not looking. You want to be a safe product, but fresh product. And the same way, low moisture food such as spices, fruit powders, nuts, these are low moisture product. And as I mentioned previously, in one of the slides, that we have lots of outbreaks due to the low moisture food product. So what are the technology? Because the traditional technologies such as sterilization, pasteurization based on the recharge, heating, they are not good for the sanitization of the low moisture foods. They are good for the high moisture products. So industry scientists are looking to develop newer technology which can work with low moisture products. So why there is a need to improve the quality of products? Which sector, commercial sectors are really looking into the improved food quality? So if you really see the high shelf life food, such as a canned food, you really see it has two major issues, or three in fact. The texture becomes very soft. With some, it may be desirable, but for many vegetables, it is really not. You lose the crunchiness. It significantly changes the color because it's a high temperature and higher time process. So you lose the color. The third one is the nutrient. There is a significant nutrient destruction, whether it's a vegetable or fruit. So that's a big issue with the sterilization, and especially thermal sterilization and pasteurization of fruit juices, as well as the fruits and vegetables. If you see ready-to-eat meals, this meal ready-to-eat meals used by U.S. military, and I'm sure it is used for military of many countries, because they also need a ration. When they are in the battlefield or away from the cities. So their ration quality is actually very, very poor because they are all thermally processed. And ready-to-eat meals are currently available in the market are really processed using conventional heating methods. So they are not of a very good quality. And here in the US, many restaurants our food service industry, they rely on very high quality food ingredients so that they can simply, prepare the recipes in the restaurant with minimal preparation and very small, time. so that they can really serve. They don't have a time to have food ingredients such as, let's say, vegetable, that they will buy everyday vegetable, chop them, clean, and cook. That really takes a long time. So they want is kind of a, safe, chopped, clean, partially cooked, so they can combine in restaurant and quickly prepare a recipe. Yeah, so restaurant want to create really very high quality home style cooked food, which is either pasteurized or sterilized, kind of ready to eat meals. In US, the big market for such ready to eat meals is, for example, airlines meals. Currently, they use frozen product or frozen meals and really heat them for several hours in the plane using the hot plates. And again, many of you must be familiar. If the airline meals are not really of very high quality. There are many schools, they have a lunch program where they supply the meal to a student. Right now, mostly it's a junk meal, it's just a highly processed meal. They are not supplying, ready to eat, like a home cooked meal type, recipes. Cruise ships where, again, high quality meals are really ready to eat meals are not available. Hospital and nursing home also rely on ready to eat meals, and they do not also have a time and resources to cook every day into the hospitals. So they are also looking, safe, high quality, ready to eat meals, which they can procure from the industry, simply open, warm it, and supply to the patients. NASA programs for their extended duration space mission, they also want ready to eat high quality meals with extended shelf life for their astronauts, because there's not enough space and equipment to cook food into distant planets. So yeah, there's a really big market. So really, industry is looking into new technology so that they can cater the need of the market. Another need to develop robust processing technologies to sanitization of fresh produce, low moisture product, and the frozen foods, because none of the current technology what we have developed, heat base, is really applicable to these products, because you cannot apply heat to fruits and vegetable, because if you do, they get cooked, which you don't want. You want to remain as a fresh product. Of course, frozen product, if you use any heat, you are going to just thaw them. So that those heat-based technology would also not work with the frozen product. And of course, the low moisture products are usually very, very porous. So heating of food powders or heating of nuts or spices, would also not be very effective. Of course, you can use heat to kill them, but the conventional heating, which is the conduction-based heating, does not conduct very well into this, because they are highly porous. Highly porous products have a very low thermal diffusivity and conductivity. So the conventional heating with air or steam, does not work very well. It's highly inefficient. So there is a need to really develop the newer technology to address the food safety issue with these kind of food products. So now let's go through some of the technologies. So I will talk, like a multi-mode retard, microwave-based technologies for sterilization and pasteurization, pulse electric field, and the high pressure. So what is multi-mode retard? So traditional retard, where you would first package the food in the can and then put these hundreds and thousands of can into the retard and supply steam and raise the temperature and kill the pathogens and spoilage microorganisms. But for most conduction heated products, the heat transfer is slow. So what industry has done, they have created multi-mode retard, where during the processing, you can agitate the food containers as we do at home cooking. We use a stirrer and we keep rotating, agitating the food so that there's an even distribution of heat. So there, of course, they are enclosed containers, so they do some sort of a rotation kind of end over end rotation or axial rotation or linear movement. Some way they agitate the container so that the heat transfer is improved and you get better quality product. And the most recent retard, they do not only use steam, but they also use a steam and air mixture, or they use high temperature, high pressure water only to heat the products, or they use water spray. So using different type of heating media, depending upon whether you are having the metal cans or glass containers or polymeric pouches or metal foil based pouches, you can use the right heating media to have improved rate of heat transfer, which gives you shorter processing time. As a result, you get improved product quality. There's a new development using the microwave technology to do the thermal processing. This technology is actually developed here in our university, Washington State University. This works very similar to like a retard as an in-package process technology. So you would first package your food, but of course you cannot use metal cans because microwave is not transparent to metal. So, and microwave is transparent to the glass, but glass is not really preferred material for food packaging because it's a very high density material. It is fragile, so there's a lot of liability from industrial perspective. So the polymer packaging is the right material for the microwave thermal processing. The technology which we developed, my colleague Dr. Tang, he has been working on this development from last 20 years, and I supported her effort by developing the high barrier packaging. And this is how I grew my packaging program to serve his needs for his microwave technology. In this technology, we use 915 megahertz frequency of microwave instead of 2450. 2450 megahertz is used for domestic microwave oven, and 915 is a lower frequency, but then it has a higher wavelength, so it has a larger penetration depth, so you can have larger packages which you can thermally sterilize. It's a single mode cavity. It means the microwave field is fixed as compared to 2450 in domestic ovens where microwave field is not single mode. That's why you get a lot of non-uniformity in heating, and sometimes you must have experienced that some part of the food is cold and some part is hot because it is not a uniform heating, not uniform electromagnetic field within the cavity. But using the 915 megahertz electromagnetic wave and single mode cavity, the microwave field is more uniform and fixed. And in this kind of a design, you have food packages which are conveyed through the water tunnel, and then you have the microwave energy coming from the waveguide. And at high temperature, in the range of 120, 130 degrees C, this water is transparent to microwave. So whatever energy you bombard, it goes through the water, but does not heat the water. It goes into the food and heats the food. So you put the food product or pouches or trays from one side. You preheat the your product using the hot water. Then it conveys through the water tunnel, bombarded by the microwave, where your product reaches to desired heating temperature. Then goes through the holding section, where you achieve all the microbial kill, and then you cool the product. And because the volumetric heating through microwave, unlike in a conduction heating, which goes from surface to center, it is extremely quick. So the entire microwave heating part is about 2 to 3 minutes, as opposed to in retard, where you are spending probably 1 hour or more for the cans. Of course, there is some time for holding and cooling. So altogether, this process may be 15 to 20 minutes as opposed to more than 1 hour for the conventional retard. So this way, you are able to get extremely high quality product. And this technology was patented and licensed to a company called Non-15 Labs. And apparently this company was recently bought by Tata, which is all you know as an Indian company. And they have set up a plant in Sri City in Andhra Pradesh. The city is about, I think, 50, 60 kilometers north of Chennai. And they are having a big plant and where they are commercially producing. And this is how their packaging looks like. Currently, when I talk to these people in Sri City, they said these packages are being available mostly in Pune, Ahmedabad, and Mumbai area. And slowly they are going to expand into the entire country. Yeah, so this is a very, very recent technology which has really, revolutionized the sterilization and pasteurization both, and able to deliver very high quality product. Another technology where our scientists, engineers actually from Washington State University has really contributed significantly in the commercialization, where we use extremely high pressure, which is generated by the hydrostatic pressure, to pasteurize the food product. So basically you have the packaged food, you put into the water. Of course, you use also flexible packaging, or at least one surface should be flexible so that it can transmit the pressure. And you put that into the water, and then using mechanical pumps, you compress the water. And because water is not very compressible, it has about 20% compressibility, but the rest of the pressure is really transmitted to the food and eventually to the microbes which are present into the food. And the mechanism is that, it increases the permeability of the membrane of the microbes, and then eventually leading to, breakage of that membrane, and then they lose ability to multiply. So this is how you can basically inactivate the microbes. And because there's no heat involved in it, you have extremely high quality product. So the sensory quality, color, nutrient, you have significant retention as compared to thermal processes. And this technology has been successfully commercialized. Of course, not all the products are being commercially pasteurized or sterilized using this technology. We have few number of products, but they are selling it very well here in US, in Japan, as well as in Europe. And the products are mostly beverages, like a fruit juices, and also you have some meat products such as chicken and bacon and so on. And one of the famous products, which is pasteurized using high pressure, is the guacamole, which is basically avocado-based paste, which we could never produce commercially using any of the method available before, for example, heat. Yeah, so this technology has started penetrating into the market. So about 30 plus years of research really led to a successful commercialization of this technology. Another technology which was significantly investigated is the pulse electric field, where you apply very high voltage electricity in the range of 20 to 80 kilowatt, using the electrodes for a fraction of seconds, 1 to 100 milliseconds, not even 1 second. And then, this kind of electricity creates the electroporation into the microbes. So it initiates the pores and creates the water influx. And as water goes inside the microbes, it swells, and eventually there's a membrane rupture, and the cell will die. Of course, the efficiency of this process depends upon a lot of process variable, like how much electric field you have, what is the pulse width, frequency, duration, treatment time, energy, and so on. Of course, a lot of investigation was done, and there was one company which really started pasteurizing the fruit juices and liquid eggs, and they were really of very high quality. But of course, the cost of the technology was very high, and they could not really survive and compete in the market. So they kind of closed that company. But then those units which were produced for pasteurization of fruits and juices eventually were investigated by the potato industry, where they are using pulse electric field to give the treatment to potato before making French fry. And by this treatment, they are able to literally control the intracellular compound, which are really present into the tissues of the potato. For example, reducing sugar, the release is controlled or the slow down. Because it is release is controlled, now the French fry which we make from the potato, which are treated by pulse electric field, they tend to have the less browning compared to one which are not treated by pulse electric field. So this technology is really commercialized. It's being used in Australia, New Zealand, and here in US for the pre-treatment of French fry potatoes. So these were technologies for the existing fruit juices in a high moisture product, where you are converting the product into something else. So now let's look at some of the technologies for the improving the food safety for the fresh produce. So currently, many vegetables, they are going through the chemical sanitization. So basically use sodium hypochlorite or calcium hypochlorite to give a wash to your fresh produce. Of course, there is always concern of chlorine residue on the surface. So that's, industry has been looking at the alternative method. They continue to use because we still do not have the good alternate, but industry is really very keen. And the technology which we are also investigating in our lab in collaboration with USDA is the gaseous chlorine dioxide, because gas can easily penetrate into the large bulk material. If you have large bins of carrots or almonds, you can very uniformly distribute the gas, and it seems very attractive alternate because it can reduce the production of trihalomethanes or chloramines, which are not good for our health. So those residue can be reduced. So far it has been tested in the laboratory level with limited number of products. For example, high moisture products, you could see about 3 log reduction in pathogens, and with the dehydrated products up to 2 log reductions. So there is a really need to investigate further and improve the efficiency of sanitization of fresh produce or dry nut surfaces using chlorine dioxide. Another technology which has been really investigated heavily here in the US and also in Europe is the cold plasma, which is basically partialized ionized gas, which consists of lots of ions, electrons, and photons. And they are really can damage the microbial DNA, cell membranes, or other cellulose component to make them inactive. So either you can use plasma directly, you expose your surfaces of your fresh produce directly to the plasma, or you can have plasma dissolved in the water, and then you can use water and you can use to wash the vegetable. So both way you can sanitize. And it has shown good 3 to 4, sometimes 5 log reduction in common foodborne pathogens. So this looks very promising, but all work so far has been at the laboratory scale. It needs to be researched with multiple type of food products and many different foodborne pathogens. And then scientists had to look also in the industrial scale system. So scale up would be a challenge which they need to address. Another emerging methods or technology is the radio frequency method for the pasteurization of eggs as well as the low moisture food. Currently in US, a small percentage of eggs which are pasteurized using hot water, So of course, as all you know, that the egg white, it can coagulate at 60 degree. So the heat treatment is done below 60 degrees C, but for a very long period of time to have the 5-log reduction of salmonella, which is the pathogen of concern with egg. So to address this, because it's a very slow process and less efficient, they are investigating RF heating, which is lower frequency than the microwave. It is 27 megahertz. So it has a longer wavelength, even more than microwave of 915 megahertz. So it can really penetrate very deep. So you can have the whole egg between 2 electrodes, and the entire radio frequency wave can go through the entire egg. And of course, the dielectric property of the low moisture food favors better RF heating. So both, whether eggs or low moisture products such as, nuts or spices or food powders, they can heat very well. And using that heat, you can kill the pathogens which are there on the surface of the food products, such as these spices and nuts. So yeah, this seems very promising, and now industry is looking into scale up related issues, and they are hoping. So here's one of the system developed by USDA, online system or continuous system, I should say, for pasteurization of eggs using radio frequency method. Another method which is also being investigated very heavily is the UVC light, wavelength of 250 nanometer, as well as far UV, which is 220 nanometer frequency wavelength, has shown germicidal effect. And these kind of ultraviolet light affects the microbial DNA and makes the virus or virus RNA, makes them inactive, and they fail to reproduce. As you all know, the UVC based technology is commercialized from 4 or 5 decades, for the disinfection of air as well as the water. I remember seeing some of the water purification system even in India, where they use UVC light for the purification of water. But with the food product, it has not been commercialized yet. It is slowly penetrating into the food industry. However, the effectiveness of UVC light depends upon how much a dose you are applying. Of course, you can sanitize only surfaces. It does not penetrate into the food product. It can penetrate into clear water. That's why you're able to, purifiers, or sanitize the clear water, but not the whole, product. But wherever there is a, need to sanitize only surfaces, there it can work very well. However, the issue is because it's a light, so there is a shadow effect. So the system has to be designed in such a way that the entire surface is being exposed. So for example, you can have produce, if they're spherical in nature, can go through the rollers. So rollers are rotating it so that light is shining from the top and sides, so that the entire surface is being exposed. Or you need to flip during the processing. So scale up system design is still a challenge, which industry is looking into it, and there are some commercial systems. For example, there is a UVC light based tumbler for frozen food, where the lights are there on the periphery of the drum, and then you have the product such as frozen raspberries or frozen French fry, and you just tumble them so that all surface is being exposed. So this way you can sanitize the frozen product using UVC light. However, the efficiency also depends upon the surface roughness. If there is a smooth surface, the bacteria would be fully exposed to the light and can get inactivated. However, if the surfaces are rough, such as in case of raspberry, then bacteria can find spaces where they can hide, and light may not be able to reach there. Then the effectiveness of of the UVC light would be reduced. So, this technology may be good with the product which are smoother in terms of the surfaces, low surface roughness, I should say. Another challenge is that you cannot expose the human skin to UVC light, because then it can produce kind of a sunburn or a skin cancer. So the system has to be designed as like a closed system, so that the human workers and their skins are not exposed to the UVC light. So lots of research is being done, and industrial scale adoption is also slowly happening. Of course, more and more research is needed to see whether this individual technology, how effective it's with a given produce. So in summary, many of these advanced technology which have been developed have been tested and tried with a specific set of commodity for which we found they are maximally efficient. So this is where they are being utilized commercially. Where they are not very efficient, then they are not being used, or with some product they are still being investigated. And sometimes some non-thermal technology, when you combine with mild heat, it can have synergistic effect, and you could actually have better killing. For example, with high pressure, if you combine a little bit of a heat, or with the ultrasound method, which we combine a little bit of heat, then it could have the synergistic effect, and you can have better inactivation. And industrial scale adoption and economics still need to be worked out for many products. And of course, consumer education and marketing will, as always, be a very crucial driver for the acceptance of this new technology. I say, and I compare this with the irradiation technology, which was developed in 70s and 80s. And scientifically, it showed very promising. But because of this Chernobyl nuclear plant accident, consumer and industry simply did not accept that technology, even though for many products it showed a lot of promise. But if consumer doesn't accept any new technology, then of course it's not going to be commercially successful. So consumer education is also important in terms of the commercial success of new technology. With that, I complete this presentation, and I'm happy to take your question.
Thank you so much, sir. And sir, as by this presentation, we understood that most of the upcoming challenge is to preserve the safety of the fresh food. And so the question is that how people want to ask that modern technology of preservation or the traditional technology of preservation, which basically deals with thermal preservation, which of them is more beneficial or more efficient, you can say?
So yeah, thermal based technology is also efficient with many food products. For example, heat-based technologies are very good with liquid products. So all beverages like fruit juices, milk, dairy beverages, aseptic processing works very well, and it gives a very high quality product. Conduction heated products such as solid food, let's say meat or fruits and vegetable, the heat-based conventional heating technology is not very efficient because the heating process is very slow. It's based on the thermal property of the food. So that's why it is able to preserve, but you do not have very high quality products such as the canned products. So there, the microwave-based technology has shown significant prospects and promise. And we are hoping that over the next decade or two, many products would be sterilized and pasteurized using the microwave-based technology. But with fresh fruits and vegetables, where we want to keep them as a fresh looking product, we do not want to convert them into cooked product. Let's say you want to sanitize the tomato or spinach, and you want to be still look like a fresh spinach or fresh tomato, their thermal technology is not very, applicable. That's where the non-thermal technologies such as chlorine dioxide, gas, or plasma is being seriously investigated. And many of these technologies are still at the research stage, R&D, and once they show big promise, then hopefully they would be commercialized in near future.
So, taking challenge of preserving fresh fruit juices, because for fruit juice preservation also we need to give them thermal treatment, and they are not just like the fresh juice that we extract. So, is there any challenge in modern technologies of challenge of penetration, especially in cold plasma technology and UV technology in preservation of fresh fruit juices?
Yeah, so good question. You're right. Many fruits, exotic fruits, for example, guava or chiku or lychee, even oranges, they are really very flavorful. And if you do, heat pasteurization, you didn't get the same quality as freshly squeezed juice. So for these kind of beverages or products, the high pressure, high hydrostatic pressure has really shown a very good promise. And it is being increasingly used, at least in the European, Japanese, and US market. Now we see cold pasteurized, or that's what they say, cold pasteurized juice. It means that you use only high hydrostatic pressure, you are not using any heat, and you are pasteurizing fruit juices. And with that, you are able to really maintain flavor, color, and nutrient in those juices. So that has a very good promise.
And so, since you have been to European countries, and as you said that most of the thermal technologies are being, some of them are being commercially used there. So, do you feel how much difference do you feel in the cost of these non-thermal technologies and the thermal technology processed products?
Yeah, it's a good question. So, see, the challenge is any new technology which is coming, it is coming after a lot of research. And any research and development requires a lot of investment. Of course, in Europe, America, and Japan, initially a lot of investment comes from government, so the tax dollar. And once we do this research at university level, when we had to do scale up, at that place, it is really industry which has to invest a lot. And when they do a lot of investment, then the technology becomes expensive. And if the technology is expensive, then the products are also expensive. And if the products are expensive, then the marketing challenge is there. Because, let's say orange juice pasteurized using heat, if 1 liter juice is available in 100 rupees, and now you say I have a high hydrostatic pressure pressurized orange juice in 400 rupees, well, people think 10 times that, well, is it really worth paying 4 times the money for 1 liter juice, right? So yeah, these challenges do happen. So the way industry overcomes is that, initially they try to do very high value added products. So for example, let's say mango juice or lychee juice, which are very exotic, or guava juice, which is even not available as a thermally pasteurized because the quality is extremely poor. So you initially find the products for which actually there's no juice available, because if you do thermal pasteurization, you lose nearly all the quality and consumer will simply not accept. So for these kind of a new high value added product, initially when you produce, if not all, some people, high end people are able to, are willing to, purchase it at higher price. And if that becomes successful and they are able to sell more and more, then slowly, the cost of equipment manufacturing comes down, then it brings down the processing cost, and then eventually it will bring down the product cost. And slowly, this market penetration happens. Yeah, I mean, that is a reality. And what happens, let's say I'm a Tata, I already have a lot of thermal based technologies. I have invested millions and billions of dollars in there. Now you come and tell me, hey, use my high pressure, it gives you better quality product. What I'm going to do with my existing machinery, right? Because it is still good, it's still producing, so why should I throw, right? So the industrial adoption is also not very quick because it requires a lot of investment and replacement of the existing equipment. So they wait many times till the existing equipment finishes their life, and now if they had to buy another new equipment rather than buying thermal based technology, they will say, hey, let's try high hydrostatic pressure, because anyway I had to invest let's say $10 million, rather than spending in retard or an aseptic process, I'll invest in high pressure. So this is how slowly commercialization would happen.
Since you have been to being of Indian origin, so how to increase consumer acceptance of the products processed from non-thermal technologies in developing country like India?
So in US, the consumer education happens from many dimensions. So for example, through television, advertisement, people are being educated. Then they would involve material around this new technologies through schools, starting from elementary schools, even though they may not understand very well, but at least they will hear this word. Oh, there is a new technology to boil the eggs, there's a new technology to pasteurize the juice. So because in future these kids will become really the consumer. So if they are being educated in the schools, then when they come out, they would know what these new technologies are through magazine, through newspaper, through food exhibitions. So there are many channels through which a system really attempts to educate different segment of the consumers. Of course, the effort has to come from government. There has to be some government spending. There has to effort come from media, that when you are advertising for such technology, they're not charging very high, so that you are able to afford those advertisements. Through for example, in US, let's say you have National Geographic or History, those educational channels, which are less expensive, many people have it at home. So through this, people can create a lot of programs to educate the consumer.
Like UV radiation technologies, it is often seen, or it's so that they modifies the compound present in the food, like production of free radicals and all that. So how does that justify?
Correct. But this free radical generation doesn't happen in all products. And that free radical generation also happens depending upon how much a dose you are applying. So if you really apply extremely high dose, and especially if you have high lipid-based products, then it has some quality issues. But if let's say packaging surfaces, if some fruits which are smooth in nature, for example, apple, pear, plums, then it's very effective. So those kind of products, you do not see that level of RV, so no free radical generation. So you avoid sort of high fatty, high lipid products, but dehydrated products, or let's say spices, or fresh produce, fruits and vegetable. It is quite safe and is able to have high quality.
Yes, sir. So overall, a lot of innovations are being done. So I think is to choose the method of preservation wisely, depending upon the product.
That's correct. Yeah. So everything has to work. Science has to work, economics has to work, and consumer acceptance has to be there. So many entities have to come together in order to make it commercial success. So in the US, there is a system where government, industry, and academia, there are platforms. They connect each other. They come together, identify the problems, and find the solutions, and then do the marketing of those products. And where they are able to have this level of collaboration, a partnership, they have been reasonably successful in bringing technologies and products in the market.
So it overall, both the lectures were very informative, and the participants were very, you have delivered lectures with a combination of knowledge and a great presentation. So thank you very much for giving a valuable time to us. And now I would like to ask Shwetara ma'am to please conclude the session.
Thank you, Neha. Thank you, sir. Such a nice presentation. Yes, sir. You can. No problem.
It was wonderful presentations being made by Dr. Sablani, and the information pertaining to all plasmas and UVs and electric fields, and it was like very, very good, and with all pictorials, and the way he speaks is like so convincing actually, and it seems a true teacher is teaching actually. So that takes a lot of attention of the students, and we were like fixed onto the screens, my students and everybody. So I appreciate your contribution from the core of my heart, Dr. Sablani. I would like to tell you that many of the students nowadays, they are into the process of going to different US universities for their postgraduate admissions and others, and such students who are just planning to be there, so they would be very, very impressed by the way you teach. So I thank you very much for this. And once again, I would like to invite you here whenever you get time. So please do come to GBPant, and we would love to host you here in Department of Food Science and Technology. We look forward for different collaborations and integrations with Washington State University, and specifically with you for different purposes related to students and some research projects also. Thank you very much, sir. Thank you.
Thank you, sir. Thank you so much. Now, official vote of thanks from my side. Very good morning to everyone. I am happy to present our vote of thanks on behalf of the Department of Food Science and Technology. I would like to thank our expert, Dr. S.S. Sablani, Professor, Washington State University, for enlightening us with their knowledge and experiences. And today's lecture were full of knowledge and interesting things, and it gave deep insights into the topic and also revealed some interesting facts about future outlook of the food packaging and food safety challenges and their solutions was really informative. And I'm pretty sure the precious knowledge that Professor Dr. Sablani gave us will definitely help us in our studies and research. And once again, I would like to thanks for taking out time from their busy schedule and enlightening us. And sir, we will continue to take your guidance and during the training and lectures to be held in our department in future. And now I would like to thank our Vice Chancellor, Sir Dr. Tej Pratap, Dean College of Agriculture, Dr. H.K. Kashyap, Sir, PI, IDP Nahib, for their support and giving permission to organize this lecture series on the advances of food science and technology. And I want to thank our head, Dr. S.K. Sharma, Sir, for their motivation and guidance. And now I want to thank Dr. Chopra sir, Dr. Anil sir, Dr. Sabhu Sangeeta, Dr. Simran Kaur Arora, and all members of this department. Now I not forget to thank my dear students, Neha, Taru, Riya, Nazim, Santoshi, Aruna, Meghna, and Himanshu, who really work hard to make this event successful. And also thanks to all the participants present here for paying your attention and learning. Thank you so much to all of you to make our event successful, in fact fruitful also. Thank you, sir. Keep in touch.
Okay, well, thank you all for listening to me for 2 hours or more than 2 hours, and hosting me for this webinar. Thank you, Dr. Sharma and Dr. Roy, for inviting me to present my talk. Sorry to students, yesterday there was some miscommunication or confusion in terms of the scheduling, so that's how I missed the lectures yesterday, but well today. Yeah, and I really enjoyed, and yeah, I look forward to continue interaction with the faculty and students of your institute. Yeah, very good. Thank you.
Thank
Thanks
you so
all.
much. Okay, good night.
Good night. Yeah, bye.